Our first topic of the solution is motion laws, application of motion laws. And motion law means the laws of the Newton, motion laws of Newton. And for solving and application of these law, first question has been selected from paper 9709/43 for the session May June 25, and question number 5 belongs to the mentioned topic. Let's read it. A van of mass 2500 kg traveling at speed v meter per second experiences a resistance force of k v square Newton. The constant power of the van's engine is 62.5 kilowatt. The steady speed that the van can maintain when moving along a straight horizontal road is 50 meter per second. So that k is equal to zero point 0.5, and find the acceleration of the van when its speed is 25 meter per second on this straight horizontal road. So all of us know what the Newtonian motion laws are. That is simply the direction is, look at this, the van is traveling at a horizontal road. Look at this, along a straight horizontal road. So direction is just horizontal, okay? And the motion law, we know that it is nothing but driving force minus resistance to motion must be equivalent to the product of mass and acceleration. And driving force is equal to, we know driving force of an engine is actually power over velocity, power divided by velocity, minus resistance to motion is already given. Look at this, they have written there is a resistance force of kv square. This is our resistance to motion, so kv squared. And what's the state of speed? It is moving at a constant speed. As the speed is constant, there is no acceleration at all. That means right side is 0. And power is given, how much is the power? Power is given 62.5 kilowatt. This is our power. So 62.5 means 62,500. So let us write 62,500 watt over velocity is written over here. It is 50 meter per second when it was moving at a constant speed, divided by 50, and velocity is 50, so 50 squared k is equal to 0. Now if we isolate our k, then it is going to be, if 62,500 is divided by 5, it is 50, it is going to be 1250. So 2500 k is equal to 1250. Hence if we dissolve these numbers, it is going to be k is equal to zero point 0.5, zero point 0.5, and they have told us to show that, so we have showed. Well, let's move on to the next part. This is not the this is not all of the solutions. It's actually they have told to find the acceleration of the van when its speed is 25 meter per second. So for acceleration, the concept will remain same, that Newtonian motion laws, but the quantities may be different, because at this time it is no more constant speed. So let us apply the same concept. The concept is motion law of Newton, and direction is also same. The van is moving in a horizontal direction. The concept is a driving force minus resistance to motion is equal to mass into acceleration. Driving force, we have already come to know, driving force means power divided by velocity minus resistance to motion. Okay, resistance to motion is kv square. K has been obtained as 5, and then v square is equal to mass of the car was 2500, and they have told us to find acceleration. No, so let it remain unchanged. Now power is 62,500. We have already used 62,500, and velocity at this stage, velocity is different. Look at this. Initially they told that velocity was 50, but now velocity has become 25 meter per second. This is our velocity. So let us write 25 minus zero point 0.5 into velocity is 25 squared. 25 squared is equal to 2500 A. Or if we simplify the left side, it is going to be 2500 minus 2500 minus 3000 312. 312.5 is equal to 2500 A. Hence our A is going to be, denominator is 2500, and numerator is, if we subtract 312.5 from 2500, it is going to be 2187 and finally our acceleration is going to be 0.87. Oh, it is a round figure. No, this is not rounded figure, this is exact figure. So let us write 0.875 meter per second square is the acceleration when velocity was 31 meter per second. So that's all about the solution to the first question. Let's move on to the immediate next part of this question. Question number B, which has been printed on the next page. It says the van begins to ascend a hill inclined at an angle theta degree to the horizontal. That means the van is no more moving on a horizontal road. The van travels along a line of greatest slope of the hill. The speed of the van at the start of the hill is 20 meter per second. And its acceleration is 5 meter per second square. Later, on the same hill, the speed of the van is 30 meter per second and its acceleration is a meter per second square. The power of the van's engine remains 62.5 kilowatt and the resistance to motion is also zero point 0.5 V square Newton. Find the value of alpha or acceleration and the value of theta. So let us apply the same concept, and direction is now different. It is just moving on an inclined hill. So the concept we have been applying is driving force minus resistance to motion is equal to mass into acceleration. So driving force is, let me show you through a diagram. So this is the van and this is normal reaction, this is weight. Yes, this is the diagram, and the van is moving upward on the inclined mountain. Well, then our driving force is the same formula. Concept is power over velocity minus resistance to motion is also unchanged, which is zero point 0.5 v square. 0.5 v squared equal to mass into acceleration. Okay, acceleration is to be obtained and mass is 2500. So then, but we should not ignore another concept. Look at this here, weight is also causing a resistance to motion, so we should not ignore weight, which is mass into mg sine theta. Mg sine theta, remember, weight should not be ignored because weight is a kind of force. In this case, this is resistance force. Then right side is 2500 A. A is acceleration. Now power is same 62.5, so 62500, and velocity in the first case Look at this. First case, velocity was 20 meter per second. So let us write 20 minus zero point 0.5 into 20 squared, 20 squared, minus mass of the car is 2500 and acceleration due to gravity is 10. So this is going to be 25,000 sine theta. Sine theta is equal to 2500 A. We have already made a mistake in the second step. Look at this. Acceleration is given 5a. So acceleration is not a, it is 5a. Now if we multiply 12,500 by 5, it is going to be 2500 multiplies by 5, it's 12,500a. 500a. Then on the left side, if we simplify this, it is going to be 3125. 3125 minus 200. 400, half of 400 is 200, minus 2500, 25,000. It should not be 100, it is 1000. 25,000 sine theta. 25,000 sine theta equal to 12.5 thousand A. 12,500 A. Then if we isolate our sine theta, then we can form an equation, and we'll have to form two equations. Remember, as there are two values to be obtained, so there must be two simultaneous equations. Or our sine theta is going to be, if we isolate sine theta is going to be 2500. All the symbols should be simplified. Then it is going to be 2925. 2925 minus 12,500 A. 12,500 A over 25,000. 25,000. We have dissolved the symbols. Please don't get confused. 12,000, 2,000, 25,000. And this is equation number 1. Then as the direction is same, we are going to apply the same concept with the same direction. For the second phase of the journey, it is still now it is moving in the same direction. That means traveling on the inclined mountain. So our concept is also same. Driving force minus resistance to motion is equal to mass into acceleration. And driving force here is power over velocity minus resistance to motion is also same. 0.5 v squared minus mg sine theta. That means weight is also causing resistance to motion. Mg sine theta is equal to 2500. Is mass is 2500. And our acceleration, let us see what is the acceleration in the second phase. In the second phase, look at this. Acceleration, velocity is 30 meter per second, acceleration is a. So it is going to be simply 2500 a. 2500 a. Well, then let us substitute the values. Power is 62,500, and we have already seen velocity is 30 meter per second. 0.5 into 30 squared minus mg sine theta is 25,000 sine theta. We have already written it in the previous part. 25,000 sine theta equal to 2500 A. After simplification, we will get 20833.3. If we divide this, 208.333 minus 450. Half of 900 is 450 minus 25,000 sine theta equal to 2500 into acceleration, 2500 into acceleration. Well, if we isolate our sine theta again, it is going to be resolving the symbols. It is going to be 2500, I mean 16.33. If we subtract 450 from 2083, it is going to be 1633 minus 33.33. We should not ignore the fraction. 33 minus 2500 into acceleration, 2500 into acceleration over 25,000, and that may be equation number 2. And if we observe both the equation, left sides are sine theta. Okay, on both cases left side is sine theta. Here, since left sides are sine theta, so surely the right side will also be equal. Okay, so let us write from equation, from if we subtract equation 2 from equation 1, it is going to be, let me find some space on the right side. I think I can continue. Okay, our equation 1 is 2925 minus 12,500 a over 25,000. Let it be written on one side. 2925 minus 12,500 a over 25,000 equal to, the right side of the other equation is, 1633.33 minus 2500 a over 25,000. So let us substitute this. 1633.33 minus 2500 a, 2500 a over 12,500, sorry, 25,000. It is 25,000. So from both sides, if we multiply both sides by 25,000, it is going to be just 12,500, negative 12,500 a, then plus 2,500 a, 2,500 a. Then if we subtract 2925 from 1633.33, it is going to be negative 1291. Okay, 1291, 1291.67. And on the left side, if we do subtraction, it is going to be just 10,000. 10,000 into acceleration is equal to 1291.67. So if we divide both sides by 10,000, it is going to be, acceleration is going to be 0.129167. If we round it up to three significant figures, it may be 0.129 meter per second squared. Okay, meter per second squared, that is the value of acceleration A. Now we are going to find the second value, that means the value of theta. Hence our theta is going to be, hence theta is going to be, any of the equation can be picked up. If we pick up the first equation, it is going to be 2925 minus 1200 12,500 into 0.129167 divided by 25,000. So our theta is going to be, if we transpose sine to the other side, it is going to be sine inverse of 2925 minus 12,500 into our acceleration 0.12916. Remember, we will have to take some more digits after decimal point for more accurate answer. Then our theta is going to be only 3.00 degree. 3.0 degree. So our answers are, what are our answers? The theta is 3.0 degree, where acceleration is 0.129 meter per second square. That's all about this question. Now let's move on to the other question under the same topic. The immediate next question has been selected from paper 9709/45 for the session May June 25, and question number 2 belongs to the motion law, concept of the motion law of Newton. Let's read it. A machine for driving a nail into a block of wood causes a hammerhead to drop vertically onto the top of the nail. The mass of the hammerhead is 1.5 kg and the mass of the nail is 0.005 kg. The hammerhead hits the nail with speed 32 meter per second and remains in contact with the nail after the impact. Calculate the speed with which the combined hammerhead and nail move immediately after the impact. Give your answer correct to 3 decimal places. So, though our topic is motion law of Newton, as this part of this question related to our concept, mentioned concept, that's why we will have to solve this. For finding the velocity, look at this, they have told us to find the speed of velocity. For velocity after collision, we apply the conservation of momentum. Though it belongs to different topic, we will have to solve this, because extracted information, the information we will extract from this will be used later on. So let us apply the conservation of momentum. Conservation of momentum is mh, that is mass of hammerhead into initial velocity of hammerhead plus mass of the nail into initial velocity of the nail is equal to mass of the hammer into velocity after the collision, velocity of hammer after the collision, and mass of nail as well as into velocity of the nail after collision or after hitting. So the mass of the hammerhead or hammer is 1.5, 1.5, 1.5, and initial velocity of hammerhead is given as 32 meter per second. 32 meter per second plus nail. About nail, it was 0, actually it was at rest. Okay, so mass of nail is 0.005 into 0, because the nail was at rest before the collision or before the hitting, and after the collision mass will remain same as it is 1.5, and velocity is to be obtained, and mass of particle in, I mean nail, is 0.005 and velocity is to be obtained. If we simplify our statement, then it is going to be 48 is equal to 1.5 plus 0.005 is actually 1.505. 1.505 v 1.5, because after collision both the hammerhead and the nail were in contact with each other, that's why the velocity will remain same. Hence velocity after the impact is going to be 31.31.89489 meter per second, meter per second. Well, and if we round it up to three significant words, I think they have told us to write three decimal places. That's why we have written 894 after decimal fraction. Then let's see what B says. B says there is a constant force resisting the motion of the magnitude 25,000 Newton. Calculate the distance the nail is driven into the wood. So for distance, always we opt for the Shubert formula. It belongs to kinematic. But before that, Shubert formula always requires acceleration. So let us find the constant acceleration. And for acceleration, always we apply the concept of the motion law. So the direction of the nail and hammerhead is down, vertically downward, and our concept is driving force minus resistance force is equal to mass into acceleration. Let us see what is the driving force actually. What is the external force? Hammerhead and the nail, actually they are, hammerhead is hitting the nail vertically downward. There is no other forces acting on hammerhead except the weight. Okay, so we will have to write mg, driving force is mg sine 90 degree. Sine, you may please don't get confused, we are not ignoring the weight. You cannot ignore the angle also. So minus resistance to motion is given 25,000, 25,000 equal to mass of hammerhead and nail, it is 5.00, sorry, 1.505. Let me show you, it is 1.5 was the mass of the hammerhead and 0.005 is the mass of the nail. So it is together because they have remained in contact with each other. So total mass is 1.505 into acceleration, into acceleration. Well, so mass of both of them combined, it is 1.505 into sine 90 is 1. Okay, and acceleration due to gravity is 10 minus 25,000 equal to 1.505 into acceleration. If we isolate our a, means acceleration, it is going to be negative 24,984, 24,984.95 over 1.505, 1.505. Okay, then our acceleration is going to be 16, it must be negative, negative 16,601, 601.29568, 29568. We have taken some more digits after the decimal point than it is necessary so that we get more accurate answer. So our acceleration after the impact is negative 16,601.29568 meter per second square. Now we will find our the distance. They have told us to find the distance, and for distance we will apply the Shubert formula, which is v square is equal to, we know v square equal to u square minus u square plus 2as. Okay, now changing the color, so v square is equal to, v square equal to u square plus 2as is the concept we are going to apply to find. S stands for displacement, and final velocity was definitely 0. Look at this, when the nail was hit by the hammerhead, finally it got stuck. That means the final velocity was 0. And let us see the initial velocity also. Initial velocity has been already obtained. We have found after hitting the nail, the immediately after that the initial velocity was 31.894 meter per second. So let us substitute all of these values. Initial velocity, final velocity is 0. Initial velocity was 31.894, 31.894 squared, and our acceleration is, look at this, this is deceleration, means negative acceleration, so we will have to use negative symbol. Let us use negative symbol. Negative 2 into acceleration is 1660101.29568, 2 into s. Now if we isolate our s, it is going to be, it is going to be 31831.894 square, 31.894 square over 2 into 16,601.1.29568, 29568 and 8. So finally our displacement is going to be 0.0306, 0.030306, if we round it up to three significant figures, okay, or three decimal places. So that is what the final displacement which has been traveled, distance traveled by the nail after hitting by the hammerhead. Now let's move on to one more question. This is not meter per second, sorry, it is displacement, so let it be written as only meter. So displacement or distance is 0.0306 meter. Let's see the next question. The immediate next question has been selected also from the same paper, I mean 9709 slash 45 for the session mentioned 25, and question number 5 belongs to our discussable topics. It says a car of mass 1500 kg is traveling along a horizontal road. Look at this, this is along a straight horizontal road. It is given that there is a constant resistance to motion. The engine of the car is working at 24 kilowatt while the car is traveling at a constant speed of 32 meter per second. The power is now increased to 28 kilowatt. Find the acceleration of the car at the instant it is traveling at a speed of 36 meter per second. So we are going to apply the same concept, and the direction is actually horizontal, straight horizontal direction. Concept we have been applying is driving force minus resistance to motion is equal to mass into acceleration, okay. And what is the driving force? The formula we have been applying is power over velocity, and resistance to motion is, look at this, resistance to motion is given somewhere, or it has been constant resistance to motion. Resistance to motion is not given, remember, so we will have to find it. That is frictional force, okay. Resistance to motion means here frictional force. So for frictional force, at the same time one more force may be ignored. Sometimes you get confused that sometimes we calculate and consider weight, sometimes we don't. Actually every time we calculate and consider weight. Let's see how. It is mg cos 90 degree, okay, because this is horizontally straight, equal to, so sometimes some teachers may not write this weight, it may remains invisible, but definitely it plays a role, and this is the component of the concept of motion law of Newton. So please don't get confused that sometimes we are to use weight or apply weight, sometimes we are not. Actually that is not the fact. Fact is every time we use the weight, sometimes it is as driving force, sometimes as frictional force or resistance force, not frictional, resistance to motion. So this time we are using as resistance to motion. And mass into acceleration is zero because it is traveling at a constant speed. Look at this, constant speed, so it is zero. Then power is given 24,000, 24 kilowatts, so 24,000, and velocity is 32 minus frictional force is to be obtained equal to frictional force, and cos 90 is 0. So adding and subtracting 0 causes no change to the quantity. So our frictional force is, if we divide 240,000 by 32, sorry, 24,000 by 32, this is our frictional force is 750 Newton. Well, whenever we find our frictional force, now easily we can find our acceleration as well. So direction is same, still the car is moving on a horizontal straight road, and the concept is also as usual same, driving force minus resistance to motion is equal to mass into acceleration. Well, so driving force is P over V, power over velocity. Power is, how much is the power? Power is 28,000 this time. I am going to show you 28,000, and velocity is 36. Minus frictional force we have just found 750, and if you question about the weight, we are writing mg cos 90 degree is equal to mass into acceleration. Mass of the car is 1500 kg, so it is going to be 1500 into acceleration. Well, let me show you where we have got this 28,000 and 36. Look at this. In the second phase of the journey, the power is 28,000, 28 kilowatt, and velocity was 36. They have told when the velocity was 36 meter per second, find the acceleration. Okay, that's why we have used 28,000 instead of 24,000 and 36 as velocity instead of 32. If we calculate this, we are going to find 1500 A is equal to, everywhere there is a zero. Okay, so this zero can be dissolved from everywhere. So 150 A, 150 A is equal to, this is also zero. Okay, 150 A is equal to 28,000, 2800 over 36 minus 750, I mean 75. 75. If we isolate our A is going to be 2800, 2800 over 36 into 150, 150 minus 75 over 150. Hence, finally, our acceleration is going to be, using our calculator, we are going to find it 0.0185. 0.0185 meter per second squared. So this is our final answer to this question. They have told us to find acceleration, and surely for finding acceleration we choose the concept of the motion law of Newton, and we did so. Finally, our answer is 0.0185 meter per second square if we round it up to three significant figures. Let's see the next question. The next question is printed on the next page. It says, it is given instead that the resistance to the motion of the car is 340 plus 4 V Newton when the speed of the car is V meter per second. When the engine is working at 20 kilowatt, the car is traveling at a constant speed. Find the constant speed. So concept is same, and it is still moving on the straight horizontal road. So it is driving force. Our concept is driving force minus resistance to motion is equal to mass into acceleration. So driving force is power over velocity minus resistance to motion has already been fixed, which is 340 plus V. And if you talk about weight, we are going to write mg cos 90 degree because it is traveling on a straight horizontal road equal to 0 because the car is traveling at a constant speed. Well, so power is, in this case, power is what? 20,000. So 20,000 and velocity is to be obtained. Velocity is to be obtained minus 340 minus v equal to 0. Well, then if we multiply every quantity by v, it is going to be negative v squared minus 340v plus 20,000 plus 20,000 equals to 0. We will have to factorize this, and for factorizing, let us dissolve the symbols. V squared, sorry, we skipped something. It is not 340 plus v, it is actually 340 plus 4v, 4v, so it is 4v. If it is 4v, then it is going to be negative 4v square. So 4v square by negative 4, if we dissolve every quantity, it is going to be plus uh, 485. Yes, 485 is 340, so plus 85v, and minus, if we divide 20,000 by 5, it is going to be 5,000. Now if we break up the middle term, it is going to be v square plus 125v 125v minus 40v minus the final quantity constant number 5,000 is equal to 0, is equal to 0. If we resolve it into factors, it is going to be v plus 125, and the other factor is going to be v minus 40 equal to 0. We cannot pick up, we cannot accept the first factor because our velocity is speed here. Speed can never be negative. Hence, our velocity is going to be v is equal to 40 meter per second. Okay. Since if you want to reject, you can show a cause since v is greater than 0 because it is speed. Speed can never be negative. Okay. So let's see the next question. Since there is no more question left under the topic of motion law of Newton for the session, summer session 25, so we are moving on to the next topic.